right, guys, we are almost done with this unit. We are talking about parallel lines and perpendicular lines, and we are using point slope form. That's the y minus y1 equals m times x minus x1, so that we can be given only the slope and a point and find the equation of any parallel or perpendicular line. Okay, so let's go ahead and do the odd ones together, and you're going to do the even ones on your own. Number 9 says, write an equation of the line that's parallel to y equals 2x plus 4 and passes through the point -4, -1. Okay, so if it's the parallel line, right, and they give us the y equals 2x plus 1, we know that our line parallel to it will have the same slope. So what's the slope? That's the m in y equals mx plus b. So my m is 2, right? M equals 2. And my x1, y1 is given. That's a -4, -1. So plugging that in, I have y minus y1, -1, equals m, 2, times x minus x1, -4. Right? And I have a couple double negatives here. That's going to be y plus 1 equals 2x, and 2 times +4 is 8. So the next step would be to get y by itself on the left-hand side. We're going to subtract 1 on both sides and gives us y equals 2x plus 7. So is that parallel to the line given? Y equals 2x plus 4. Y equals 2x plus 7. Well, if you're graphing that, and this is just a rough sketch, 2x plus 4, right? Oops, I didn't mean to do that. Here's +4 up 2 over 1 will look something like this. And 2x plus 7 up 2 over 1, right, would look something like this. So yes, those are parallel lines. Okay, so number 11 is going to be kind of like number 10. Right, the equation of the line that's parallel to 6x plus 5y equals -10. Well, that's not very nice of them. They did not give us the equation in slope-intercept form, so we have to convert it by subtracting 6x on both sides, and we're left with 5y equals -6x plus -10, and then we divide by 5 on both sides, and we get y equals -6/5 x minus 2, right? If we divide by 5, everything gets divided by 5. So parallel to that line, parallel is same slope, right? So if it's the same slope, and my slope is -6/5, okay, that's my m that I use in point slope form. Y minus y1, 9, equals m, -6/5, times x minus x1, -10. All right, so that's y minus 9 equals -6/5 x -6/5 times +10 is -10 divided by 5 times 6 is 12. 10 divided by 5 times 6. All right, so now to get y by itself, add 9 to both sides, and I'm left with y equals -6/5 x minus 3. All right, those are definitely parallel. -6/5 x minus 2, -6/5 x minus 3. The only thing different is the y-intercept, and it's only one away. Okay, so now we're going to try it with perpendicular lines. So we'll come over here to number 13. Write the equation of the line that's perpendicular to x plus y equals -5. You guys, I'm going to leave you that one. I'll do number 14. So I think 14 is a little bit harder. Perpendicular lines have what kind of slope? Negative reciprocal slopes. Negative reciprocal slope. So we are converting this into slope-intercept form, right? That would be 3y equals negative 5x minus 21. All right, and divide everything by 3. And that leaves us with y equals negative 5/3 x minus 7. But what do we need out of that? We need the slope. So the slope is negative 5/3, right? And that is the slope of the line given. But we're trying to make an equation of the line that's perpendicular to that line. So we want the negative reciprocal of negative 5/3, which is positive 3/5. So plugging that in to point slope form, y minus y1 equals m 3/5 times x minus x1, negative 5. Y minus 1 equals 3/5 x plus 5 divided by 5 times 3. And finally, we add 1 to both sides. Plus 1. Y equals 3/5 x plus 4. Okay, so let's go ahead and just do a quick graph check to make sure we're on the right track here. So here's my coordinate grid, x and y axis. Negative 5/3 x minus 7 would look something like this. Right, here's net minus 7. My y-intercept is negative 7. Down 5 over 3 would look something like this, right? Okay, and y equals 3/5 x plus 4. Well, plus 4 would be up here. Up 3 over 5. Up 3 over 5 would look something like this. Right, so do those look like perpendicular lines? Well, kind of, from my not very good graphing, rough sketch, but yes. Are they negative reciprocal slopes? 3/5, negative 5/3? Yes, so those are perpendicular. Okay, and I'll do number 16, the harder one, for these two types of problems. I think these are kind of challenging and fun. So xy is formed by negative 9, negative 7, and negative 3, 5. Let's go ahead and graph those. Xy, negative 9, negative 7. Here's x. And negative 3, 5. Y. And connect them. Okay. So J is the perpendicular bisector of xy. Write a linear equation for J in slope-intercept form. Graph segment xy and J to confirm your answer graphically. Okay, so I already graphed xy. Xy, what is the slope? It looks like up 2 over 1, up 2 over 1. Maybe, but let's go ahead and plug it into the slope formula just to double check. So that is y2 minus y1 over x2 minus x1. Isn't that negative 12 over negative 6 is positive 2. 2 over 1, rise over run, right? So I did not mean to erase my line there. I'll go ahead and put it back. My slope is 2. Okay, line J is the perpendicular bisector of xy. Line J is a perpendicular bisector. So two key things here. It's perpendicular and it's bisecting. So what does a bisector do? Well, it cuts it in half, right? So if it's cutting the segment in half, we have to find the point that is halfway between x and y. So what is that halfway point called? That's called the midpoint. So let's find the midpoint now. So the midpoint formula is the average of my x's, -9 and -3, and the average of my y's, -7 and 5. So that is -12 divided by 2 is -6, and -2 divided by 2 is -1. -6, -1. That is one of the points of line J. -6, hopefully that's on my line. 1, 2, 3, 4, 5, 6, -1. Oh, it is. Good. Okay, so that point is on line J, which I guess I could have kind of guessed that anyway. And if it's the perpendicular bisector, then I need the perpendicular slope. Okay, so perpendicular slope of 2 over 1. Right, what's my new perpendicular slope going to be? Perpendicular slope is -1/2. Okay, so I have my x1, y1. I have my m. Let's plug it into point slope form. Y minus y1, -1, equals m, -1/2, times x minus x1, -6. Okay, I have a couple double negatives here. Y plus 1 equals -1/2 x. Negative times positive is negative, and 1/2 of 6 is 3. Almost there. We're going to subtract 1 on both sides, and we get y equals -1/2 x minus 4. All right, so that will hopefully be our answer. Let's check. -1/2 x minus 4. So if I'm graphing that, I start at -4, and I go down 1 over 2, right? My rise is -1, and my run is 2. Down 1 over 2, down 1 over 2, and that is the same thing as up 1 and back 2, up 1, back 2, and it connects. Hooray, we did it. Here's my line J. Is it cutting xy in half? And is it perpendicular? Yes. Okay, so I think this is a good example of an EOC type question. All right. You guys are going to do all the ones I skipped. And it's going to get you ready for your test on Thursday and Friday. Good luck, and bring your questions to class tomorrow. Bye.